We have a mission at the Lake Cane Restoration Society. We want to keep it swimmable, fishable, and lovable. The lovable is part of the community.
Hello, everyone, and welcome to CCI Engineering first webcast and podcast. I'm Juan Carlos Orozco. At this time, I will serve as moderator and behind-the-scenes operator. Don't worry, we will have the best host and the best guests here, and it's not me, it's them. So as you saw on the video, and for those of you who are just listening or will be in our podcast audio-only version, this will come out handy. We are involved in an incredible project that is meant to save our lakes with science, technology, and what we have learned to call citizen scientists, okay? For those of you who are connected live, please feel free to leave comments or questions in the chat box or comment section, whether you are in YouTube or Facebook Live. We will let our guests know and answer all of them if possible. But let's get started. And I have the privilege to introduce the host of this webcast podcast, CCI's CEO and founder, Joyce Johnson. Welcome, Joyce, and happy birthday.
Thank you, Juan Carlos. So I hope all of my family is online. So this is my first podcast. It's my birthday, and I'm a little nervous about that, but here we are, and I'm kind of excited about it. I started back in the 80s with CAD concepts, and we grew and we used software and got into 2D and 3D. And then in 2012, we became CAD Concepts CCI as CCI Engineering Services. And now 10 years later in 2022, we're CCI WADR. We've added two. And the creativity and the excitement in what we do just keeps getting better. So, in aviation, transportation, utilities, facilities, all of it has a commonality, and that is the technology is similar. So working together with the group that we have, I want to introduce Jack Ray. He is our COO, and he is leading the research and development for CCI WADR. He's going to be way more behind the scenes and way far more busy. And then we have Stephen Curless, and he is the guy that is doing the building of what we're inventing here. So these guys are amazing. Jack brings the technology from utilities and aviation related to digital twin. If anyone gets that terminology now, between modeling and operating and maintaining facilities from actual models. Stephen brings the big data to the picture and the ability to build. So then we have COVID. And COVID makes us all virtual, and it makes us wonder, we have imagination, we have ideas, things start happening, and now Stephen's building on his kitchen table. Fortunately, he is still married, and his wife is letting that happen. And we have our first customer, and that's Jay Madigan from Lake Cane Restoration Society. So Jay, there you are. Yes. And I've known Jay for a long time, and he is the one that is saying, keep the lake swimmable. He came up with the idea of what do we need to see? Heads together, COVID conversations. What more can I say?
Well, really nice to be with you and the CCI team, Joyce. And I want to say that we've known each other for years, and every time we get together, I learn something from you. Lake Cane is the home of Lucky's Lake Swim. For 32 years, Lucky Meisenheimer's been inviting people to swim in his lake right out of his backyard. But now, thanks to CCI, I think we're becoming not only a fun lake, but a smart lake. You guys are making us, we're on our way to being the world's smartest lake. Thanks for what you do.
Wow, kind words, Jay. Thank you.
Sure.
Yes, I mean, it is kind of exciting. And so, I'm supposed to talk about how all this got together and how it happened, but it's so exciting to see how it works. So, to get into that, and I know that we're going to have questions, Jack, can you talk about the data? And then, Stephen, can you show some of the data that we've found and the ideas that have come from the beginning?
Yeah, certainly. Those of you familiar with CCI engineering know that we've been an innovator and pioneer in BIM and digital twin technology for more than a decade now, focusing on creating digital models for buildings, roadways, bridges that have enabled our clients to better plan, design, build, and manage their facilities, and lowering the total life cycle costs of those facilities. We came to the conclusion that what we've been doing in digital twins for buildings and infrastructure could also be generalized to environmental resources. And if we were able to create detailed, accurate digital models, it would enable us to better plan effective conservation and restoration programs and implement them more effectively at a lower cost. And more importantly, what's lacking in many green initiatives is the ability to go back and actually measure the effectiveness of those measures and identify new best practices in environmental asset management. But how do we get there? If we're going to leverage, the advances in machine learning and big data analytics, you need lots of data. You need lots of data. It's not enough to do a couple of dozen lakes. You need hundreds, if not thousands, if not tens of thousands of lake measurements. And it can't just be these surface measurements that are typically taken. You take half a dozen measurements, you may come back and revisit it in a year. We wanted to actually understand the dynamics of a lake by building a true digital model. So it's taking hundreds of measurements on the surface and at different depths in the lake. So we actually understand how the lake biochemistry and how it changes at different surface levels and across the lake. And understanding how the lake bottom interacts with the surrounding micro watershed and how nutrients are being fed into that lake.
Well, and that brings up a good point, Jack, with all of the lakes. I'm sure the Water Atlas is going to come in here at some point, the excitement of that. But, and Stephen's got, I don't know, is that Stephen that's sharing, or is that Juan Carlos? Because I'm new to this. But I do know I recognize that photo.
Yeah, that's currently my screen live.
Do you want to talk to that?
Oh yeah, sure. I'm sorry, I wasn't sure when we were.
No, that's okay.
Yeah, so my angle from this was, Jay approached us and said, hey, we need data about the lake, and Jack was like, yeah, we need a lot of data about from the lake to try to figure out how to fit this into those models. And we started off with our traditional techniques of aerial photogrammetry and multispectral photogrammetry, and we're used to building models from it, but we also approach it from a LiDAR perspective and trying to do kind of rainflow slope analysis, but from the multispectral side, we also capture near infrared to try to look at vegetation health, and derived NDVI maps from that, and what we started seeing things kind of in the lake surface, and it started asking more questions than it answered, especially in this the thermographic orthomosaic. We started seeing blooms from certain areas of the shoreline that we couldn't reconcile with what we knew about the lake, and we realized that we had to get below the surface. And so we came up with a set of mission requirements. Okay, what do we need below the surface? And we need to start putting together the pieces of this equation, because there was such a limited amount we recognized that was known about it. So how much silt is at the bottom? How much in the way of nutrients are tied up in that? And then what affects the release of things? So we wanted to find out about temperature, turbidity, dissolved oxygen, pH, dissolved solids, and then other potentially more elusive targets that we're still pursuing are chlorophyll A and potential fluorescence and nitrates. So we decided we did a make buy, and we looked at the market, and with the mindset of trying to build these citizen scientists, there were things that might have kind of squintingly done it, but they were eye-bleed expensive. So we decided to make, and our first version of it. This was our first version, and it went down to 1.5 feet, but more recent, and the 1.5 feet stuff was still very useful because we were able to capture, well, what kind of vegetation is where, especially in the more littoral areas on the first pass. And that was, we could really start articulating levels of where lakes were distressed and where they weren't distressed. And we were able to draw up more specific maps on, look, this lake isn't really very homogeneous. This, for instance, is turbidity. There are very different sections to the lake. And this, for instance, is the sensor package that we put together to collect that on the right. This underwater package. And after that pass, we were able to build a second version because our boat was modeled a little bit after other boats. It used underwater thrusters. Well, those thrusters, especially the most commonly available ones that are used by a lot of people, those were chronically disabled by the distress in the water, especially hydrilla. Anyway, so we recrafted it into an airboat so that it'll work in 2 to 3 inches of water. And instead of trolling the sensor, which had other issues, we would drop the sensor, and this worked out much better, and was able to give us slices, all those attributes, slices at every foot within the lake, and that's kind of where we've gone with it. Not sure where else you want me to go, Joyce.
Well, one of the things I wanted to mention was the reason we're trying to build a system that is cost effective is that in order to collect the data from thousands of lakes, we really wanted to mobilize the citizen scientists with tools, professional level tools that were affordable and easy for them to use. So we're automating this, we're making it easy to use so that we can spread this, mobilize that citizen scientist army to go out and collect all of this data. The second aspect of this is also in the digital twin world, there's this concept of a common data environment. So it's a set of asset attributes that you want to know. These are the types of things I need to know about each asset in a building in order to simulate its operation. So we're in the process of building, a freshwater lake CDE that can serve as a basis that we can share and distribute so that this data can be shared and used for doing data analysis across thousands of different lakes. If we don't establish a common data environment for doing that, then different lake society and organizations won't be able to share their data, or there'll be an extensive translation involved. So we're trying to establish that early on in order to drive this digital twin for lake infrastructure.
It's an exciting time. And the things that are coming out of the data that we're collecting surprise us. It's the difference between being able to study something and theorize what you think is happening versus having enough data to say, okay, we know where this is coming in the lake, and this is the data that shows it. And so you either the homeowners association or the county or the city or the homeowner, that you can point to it and say, okay, what are we going to do about this? And that's mostly what we've encountered are lakes that are homeowner association lakes. Lake Kane, we're lucky because it's a private lake, and that means that it just has to be agreeable between the people that live there. It's a great test ground. What we hope to do, and I hope to avoid swimming Lucky's Lake until we can see the bottom of the lake again. That's a challenge. Jay wants me to swim Lucky's Lake. If you're with me on that one, I hope Mary Sherritt's listening, because she said she would swim Lucky's Lake. Anyway, so if you can see the bottom, then you can definitely see the alligators. Jay, do you want to talk to what you've discovered already about about Lake Kane?
Okay, well, just so Lake Kane Restoration Society started essentially in defense mode to protect from projects that were scheduled to create runoff into the lake. We explained very clearly and publicly that this lake is a lake that is important for recreational purposes to begin with. But it's gone beyond recreation. I mean, swimming is one part of it, but really it's this relationship people have with this lake and any body of water they live near or that they care about or have property on. And that is really, people are motivated because they care. And that's what we've been able to facilitate. Of course, that begins with data. That begins with the idea that there's something that they need to address, and we help them do so. Your information that comes from CCI has been able to really help us understand what impact people's behavior has on the lake. So if you see extraordinary fertilization or a leaky septic tank, or for Orange County, a stormwater runoff from a large street that runs right by the lake, you can see the impact that has. And this data helps us to tell the story.
So how many lakes just around Orlando? And the lakes that you're talking about are not really large lakes. Well, Lake Toho, that's going to be on the 21st of February when we go put the boat in Lake Toho, I hope. How many homeowners lakes? How many? 2,000?
Well, in 4 counties, small to medium-sized lakes that are not distressed and that are surrounded by private property, we've counted about 2,800. And that's just one niche where we think what we've been doing can help others do the same. First of all, defend the lake from intrusion from around the lake, but also begin to, essentially restore the lake to better conditions.
And so if we can create a sensor group package, okay, I'm going to call it the brain, that gets deployed on, and I'm going to call it the boat, and it could be deployed differently to collect the data that we need. The ultimate goal being that everyone can see the health of their own lake, what they live around. So that's the citizen scientist. And I think that we're getting more and more people that are understanding and getting involved in the environment in general. So a citizen scientist, I know I've become one just from talking to you about Lake Kane and the other lakes that we're touching. So it's exciting that what started as a bad thing for us, which was COVID, turned into a new invention and a new direction and a and ability to make a difference for everyone. I'm excited
Here's
by that.
the main thing that helps is data visualization. We can talk amongst ourselves in detailed terms, but being able to visualize what Stephen showed on his screen and shared with us, being able to visualize that impact of behavior on the lake is what leads to decisions and changing of behavior that will help the lake.
And the ability to develop action plans from that data. So it's not just theoretical, it's be able to translate the data that's being communicated into actionable plans for each community to manage their lakes.
Yeah, there are many factors that impact a lake. We needed, and you've been part of the team that's helped give us an environmental monitoring system, basically, and how we now know how the lake has behaved in the past. We've been able to know more about the plants and animals that comprise the ecosystem. We see that that's part of the LIDAR, the aerial drone. But bathymetrically, it's almost, it's really remarkable. We have had feedback now on how the lake functions in real time. And that's how we look at the future. So we're trying, and with your input and help, we've been able to visualize all this and be able to form the plans and help people look at their behavior around the lake.
If we can make it affordable enough, then more people can do it. And that's one of our aims. When Stephen started building, he wanted to use all off-the-shelf products. He changed lenses on the drones. He changed the boat. He changed sensors. So and part of this data collection now for us is verifying that it's accurate. So self-calibrating sensors are on the plate. So that's kind of a, I don't want to talk too much about that, but understanding that you have data that you can rely on is a big part of what we're trying to do to move this effort forward.
Well, it's the old principle. You can't improve what you can't measure. You've got to be able to measure, have a baseline, then you know when you're able to improve. So to improve, you've got to be able to measure. And you guys are giving us a baseline understanding of where the lakes actually is, and how we move forward into the future. We'll be able to measure that too. We want you to come back.
Right, and also to automate things as much as possible so that you don't need to be a specialist in order to perform these measurements. That's another aspect of mobilizing this group of citizen scientists to go out and take ownership of their own lake management.
Yes, and we're also finding that some of the folks that we're talking to are coming up with different ideas of how we might help them. So the idea of how we're collecting things is growing, and the big data, that has always been something that I think people struggle with even today. Depending on the size of company and your understanding of IT and how all of that works, big data can be hard to deal with. And Stephen brings a background that lets us have the ability to not only use our data that's collected that we know is accurate, but to add data from other sensors, from other volunteers that are out at Lake Cane. And one of them is the AWOS, and any of my aviation friends on there that are listening. So automated weather observation system from the 80s. So we're getting air temperature there and wind speed and wind direction, that kind of stuff. Bringing all that together. And then Jay, there was one other sensor company that I forget the name of it.
Well, yeah. So we do have Weather Underground stationed at Lake Cane and in 4 other lakes. And we also have a company named Sentry, which is real-time microbial analysis. It's used frequently in wastewater treatment plants. This is one of the few installations where it's used in raw water resources, which is Lake Cane is considered that. And that is also real-time data paired with the weather monitoring. So we furthermore use this very Florida homegrown and valid Lake Watch program run out of the University of Florida, and that is monthly hand sampling of water quality. The Orange County has provided us multiple free tests that we're able to use and track, not in real time, but for a spectrum of water quality measures. So all this combines for Lake Cane being truly a smart lake. We've got some of the best data of any lake, and it's from that platform of understanding that we make plans for the restoration of this lake.
And the restoration is ongoing.
Yes, I would say we have much work to do. There are non-point source continuous trouble spots for us. We also have the bottom of the lake, which has a great deal of uncoagulated biomass and some muck as well. Part of the reading from the bathymetric analysis you're doing is helping us to see soft bottom from hard bottom and understand where we really need to focus and clean up that bottom. And we have we're focusing in on a couple approaches to get the bottom of that lake oxygenated.
Yeah, the combined topographic model between the micro watershed surrounding the lake, along with the lake bottom itself, enabled us to do things like identifying exactly the surface area of impermeable surfaces around the lake, where the water flows are actually coming into the lake, so that you can do things like doing point source filtration, identifying where the best location for those things are to have the biggest impact to reduce and filter the greatest amount of water that would be naturally flowing into the lake. But it enables other things like being able to identify if you want to do, like, introduce carp for doing controlling some of the hydrilla and stuff like that. You can use the bathymetric map for the lake bottom to identify the best locations for fish habitats to be introduced. So there's a lot of data that you can use just with the topographic models that can be used to do some preliminary civil design as well.
So when you guys talk about big data, how big?
What do you mean by how big?
How big? Terabytes? Gigabytes?
Well, it's not just the size of the data; it's the size. You have to have a sufficient statistical significant number of lakes with a statistically significant number of measurements over time, so that you can actually see how the lake is reacting to different conditions during the seasonal flows, but also in reaction to some of the remediation efforts that you may introduce. It's not enough. There's not enough data in a couple of lakes or even 10 or 100 lakes to start really fully exercising the power of machine learning and big data analytics to identify new relationships and new causations and correlations that may not be obvious by just looking at the data individually. But I would say, at least hundreds or thousands of lakes. And that's part of what's driving us. This needs to be a community effort. It can't just be CCI WADR doing this. We need to engage a community of people who are passionate, like Jay is, in conserving and restoring their lake's health and natural beauty, and sharing this information with each other to fully drive this program.
Oh, I totally get it. And do you realize that all I asked is how big is the data? Do you guys see what I get to do every day? I get to ask the questions, and these guys come back with, "Wow, this is going to work," and it's an amazing thing. So when I get on the computer in the morning, I get photos from Steven on where he's at, on what his problems are or what his challenges of the day. And well, lately it's been snow because we are in Ohio. But just the idea that we get to play with this and that we get to move it forward, and it's new territory. It's all new. So if you're one of the, I noticed that Tom Panett sent in a question. He's a friend from Ohio, an attorney, and he is environmental permitting. I have no idea. That could be maybe a Stephen question. So it would come down to detail, I would think.
Well, we certainly could identify mussel locations and lakes. If Tom is talking about Lake Erie, which he probably is, the current iteration
potential habitat.
The current iteration of the WADR boat probably wouldn't work well in a large lake environment where there are choppy seas and things like that. What do you think, Stephen?
Well, the current iteration, well, the boat was designed to be the boat was designed to be extensible, and that's because it's not about the boat, it's about the sensors, right? So because we were dealing with potentially very distressed and smaller bodies of water, the boat was designed with a more littoral aspect to it. But everything is designed to be extremely modular so that, you know, the sensors, our goal is plenty of people around lakes have boats. The sensors could then be mounted on those boats. You know, again, to minimize any kind of cost, but it focus on the sensor. Additionally, the brain box could be mounted on, and has been mounted on, boats capable of handling much more. I don't want to say open waters, especially not in bad weather, but much more chop. And we have a couple of boat platforms, boat hulls currently, and it literally clips off of one and clips onto the other one. Then it's just a matter of, or even with a larger existing boat, you know, it leverages differential thrust. So that's just a matter of coming up with a particular interface to those motors. So, I mean, it can potentially operate in much larger bodies of water. Weather becomes a little more sensitive there, of course. And it would be an interesting challenge, you know, thinking about mussels and having gone clamming, that would be an interesting challenge to see what we could get out of a couple different types of sonar to see if we could identify those. Because of the multiple returns, you could definitely start to characterize that looser sediment that they're in. But that would be an interesting challenge. I don't honestly know, but the system that we've put together and the modularity certainly would allow it to address larger bodies of water.
Oh, thank you, Stephen. Tom, thank you for asking that question. And I'm excited. I know that there's some other questions, and I think Juan Carlos was going to start to address some of those.
Yes, Joyce, thank you. We have very interesting questions. And I remember, because of one of them, when we were talking off session or off camera, if you will, with Jay, and we were talking about, okay, why should we care about if we have a distressed lake, and how does a poor lake health affect me personally? And we talk about happiness at that point, and psychologically there's a very, very interesting point there. And also we talk about economics because of the value of the property around. So it's an interesting mix, because at some point it's very personal, it's talking about happiness, and then in the other hand we have this economical point of view. Could you address that, please, Jay? That's an interesting question here.
Oh, yeah, sure. Well, I mean, that's exactly where our nonprofit began, is that people have feelings about the lake. I mean, defensive feelings, protective feelings. There's a a whole lot of people who come from all around the area and even other countries will come swim in this lake, and they treasure it. So there's a strong bond, and people have fun there. It's a swimmer's lake. So there's this kind of attachment to it that people feel. And that is one element that has propelled our actions and our organizing. I donate my time. I donate money. We have a team of people who are willing to go the extra mile for this lake because we are attached to it. Now, the property owners and many are friends, they're also attached to it because if that lake goes downhill, and there are lakes that have degraded over time, they will lose money. There is an impact on property value. Now, each lake faces that dilemma, both the protective of this attachment and also facing maintenance. And if they don't maintain it, they may have, if you will, financial impact. It's more of a dollars and cents reason for getting involved. But wherever people fall on the spectrum of getting involved, we find that people are eager to work to help this lake and other lakes be the best lake they can.
Great. And we have another, that this goes because we have talked and we have promoted this concept that you told us and you were talking about with Joyce about the citizen scientists, right? So here is the question: what role do citizen scientists need to take in restoring and protecting their local lakes?
Okay, so
what is a citizen scientist,
data,
right?
Our best data over the years has come from people who are willing to collect data, sample the water, process it, and take it to a lab on a regular basis. This ritualistic commitment to sampling lake waters is what's provided us almost 2 decades of water samples. And it's from that baseline data that we can judge what improvements and defensive measures, the effectiveness of our improvement efforts and defensive measures over time. It's the citizens who are not necessarily trained in science, but are able to repeat data gathering protocol, and they do so regularly. There's more than that. It's people who are willing to flip pancakes. You know, a big part of the reason our community is around organized and fun is because we always have, or frequently have, these pancake breakfasts. We have different events on the lake. We had a float parade for a few years. This May 28th, we have the Golden Mile. It's a 1 mile swim, and the winner gets a gold medal, a real gold medal. So what we have is people who get involved for all sorts of reasons, mainly to have fun, and food counts as well.
I want to talk to citizen scientists just a minute from a different point of view, workforce development. A lot of the people that I've met around Lake Kane and some of the other work that we do in Florida has a lot of students from University of Central Florida, and they're graduate students. They're different kinds of students, but they're mostly students, and they get involved because they think they're this next generation. So, okay, I'll say it like this. My grandson says, I couldn't understand because I'm from the 19s. So being from the 19s, I think about it differently. The young people that are around Lake Kane and the university and the things that are happening with the ecology of their surroundings is amazing. You know, they want to be out there, and they are collecting data. And I've met some of them, and they're all passionate about making a change. So working with the colleges and even the high schools, especially around Lake Kane, has been really it's been exciting. There's a few I can think of right off the bat.
Yeah, well, we've had especially good interns from University of Central Florida, UCF, University of Florida, local high schools, and I mean, we had one of the lake residents homeschools her kids, and they also do data sampling.
Well,
so they work it into the science elements of their interests, whether they're committed to an engineering track, or, you know, we've had people working in various disciplines, but they can find a niche that allows them to be part of this data collection effort.
Well, you know, Jay, I've been called a compassionate capitalist, and now I can add with a planetary approach. So knowing that we work with the students, and I know that you have a kit that you give out, and
yeah.
you know, I'm supposed to be promoting what I do for a living, and here I am talking about the kits that you can get to test your own lake.
Yeah.
I thought those were amazing. You know, the giveaways that you did at the last conference, to be able to actually go out wherever you live and test your water, and then take it to the lab and understand what's in that kit and how to do that. That is a citizen scientist, and I'm excited about that. And I really kind of want my own kit. Sorry.
No, it's great. We'll get you a kit, Joyce.
Okay, that works.
And well, actually, it's great that you mentioned something of this, Joyce. But some of the questions are okay. How? Because is it like a daydream? We have this non-profit organization like Lake Kane, this private health company. You just thought about this concept about a compassionate capitalist. Is that right?
Yes.
and we have also the public sector, right? Because
well, no, I mean, I'm a consultant. I work for the public sector and the private sector.
That's right. So
well, okay, so let me say it like this. I spent the first 20 years of my life surviving. I spent the second 20 years of my life getting it. And the third 20 years, I get to invent and do it because I can. And I want to make a difference. I want to leave a legacy. I want to make sure that this next generation understands what they've been given. Sorry, Jay, I'm digressing.
No.
And one of the things about the public sector is, and Jay has experience with this, is that oftentimes there are public sector resources that you can bring in to assist you with your conservation and restoration efforts. But oftentimes you need to be able to give them some data. You know, you need to know what they need in order to make a decision on funding something for your local community lake. And so part of the citizen scientist effort in mobilizing and giving them tools is also to help them, educate them on the tools and language that they need in order to request assistance from these public sector resources.
Yeah.
If there were to be any dollars spent on something, if you could triage those dollars and that effort and time into where it matters most, then that things will become that much better because of it. And a lot of what this does helps them triage time, effort, tears, and dollars.
And I'd like Jay to talk about how this is connected. We're the northernmost aquifer in Orlando, right? For the South Water.
So, okay, so think this Lake Kane is in the northernmost headwaters of the Everglades. So everything is flowing to the south from where Lake Kane sits. And it is a phenomenon that before the settlement of Florida, it was essentially an underground river that flowed from north to south. So whatever we do in the Orlando area where Lake Kane is situated impacts the southern river and open water bodies and also the aquifer in the South Florida Water Management District. So Joyce, we have a bigger mission. It's not just what happens at Lake Kane, but what we do impacts that whole southern stream.
We're starting a movement.
We are, and
Yes.
and part of our project that you've helped us with, this Lake in a Box. What happens is Orange County is unique in Florida in that it drains in different directions. So part of Orange County where Lake Kane is drains to the south. That's the South Florida Water Management District. Some of it drains southwest. That's the Southwest Florida Water Management District. And some of it drains north, and that's the St. John's Water Management District. And what you've been doing is helping us show lakes in each of those water management districts how to begin their journey of organizing a team, collecting data, forming a plan, and then getting the right partners to make that plan work.
So that's our prototype, and it's a start. So could you name the lakes? And if anyone on the call wants to get involved, just name the lakes. I know the lakes, but I want to hear you say it.
Sure. So Lake Kane is our home base, if you will. There's Lake Hiawassee. There's Lake Horseshoe. There's Lake Minnie. And Stephen, there's one more lake, Lake Chapman. And that is in the Southwest Florida Water Management District.
So each of those lakes was picked because of where they were and how we want to collect data. And Stephen has just completed his last data collection effort. He's in the process of processing data. And we're going to have some great new videos coming from, he missed the snowstorm, but then had to dig out in Akron. Stephen sits in up near Akron. Yeah.
Now I want to say that we began our project by saying we want to make sure we get a lake in each of those 3 water management districts, but the lakes particularly were chosen. For instance, Lake Horseshoe, Scotty Warner, he is a swimmer and a very dedicated swimmer, and he really cares about his lake, and he had other, so it was his will to get his lake better that really got us to Horseshoe. There are hundreds of other lakes in that area. Lake Minnie, there was a gentleman who came to our very first board meeting. So what we did was, because he was dedicated to helping the nonprofit start, we went to his lake that happened to be in the right geographic area. And then there's, Lake Chapman, and that gentleman, Arnie Bellini, he very much supported us and really helped us get off the ground. And we are working with him on his lake too.
So CCI WADR, Watershed Autonomous Data Recorder. If you're listening and you have a lake you want us to look at, we would love to talk to you about it. We want to move this technology as we grow the ability to analyze. And it's amazing to me every day how things change. So with Jack and Stephen both working on this, I know that we're ahead of it. And I feel that it is going to make an impact on the future of the clean lakes of Florida. And that's a start. Other states later. And I know, Jay, you're from Cleveland, so the lake that burned. Oh, no, that was the river.
Cuyahoga River.
Yes. You were there then, right?
I was a young boy, and but I grew up swimming in Lake Erie. and it's a beautiful lake, a great lake, I call it.
Okay, well, it has been great talking to you guys. In addition to everything that we've done today, thanks to working with Juan Carlos, I'm also learning Spanish. And so I'm kind of excited about that as well. Okay, I understand more than I can say. So Juan Carlos, what do you think?
Well, we are really excited about all this. I have also learned a lot, not only English, but of course, all these projects made me, as Jay said, just fell in love again with swimming. I was out of swimming because of the pandemic, and I'm excited that I can be around again. And basically, it's new to me, but I will test it. I promise you, Jay. Test that natural swimming in a lake. I mean, I never done that. I have fish in a lake around here.
Yes, I'm
yeah, but overall, this whole project and working with CCI Engineering and knowing all the great stuff you're working on and the amazing team of professionals that you are around, we'll see each other soon in the real world, not only virtual. And especially in that conference, Joyce, maybe if it's good to mention here that this project and Stephen is going to be in a conference and in Gainesville, right? And
we're presenting the 23rd of February, University of Florida in Gainesville. Stephen's in the morning talking about WADR, and I'm in the afternoon on a workforce development panel. But before that, on the 21st, we're going to be in the Kissimmee office, and we'll be looking at some of the new data that Stephen's collected and possibly putting the boat out on Lake Toho there. So if you want to, ping me, some of the folks that are on here are okay. They're geeks. Those are the ones that are hanging on this call with us. You guys know that, right? Yeah. Anyway, so yeah, I mean, the 21st of February, if you're in anywhere around Kissimmee, please stop in and we'll talk to you. Jack will be there. Stephen will be there. Barb and I will be there. And then the conference. So it should be an exciting time, and it will be warm. I know that.
Yes, and we'll be making some posts and some live transmissions there, with some comments of all of you guys and covering the transmission. Please follow CCI on their own social media. You can also visit ccitext.com. And of course, there's in the screen, you can see the WADR Project website too, ccIWader.com. Feel free to contact everyone there. And I don't know, that's all. Maybe just again, wishing Joyce a very happy birthday on his first.
What a birthday gift. Thank you, guys.
Happy birthday, Joyce, and thank you, CCI, and everybody for all the good work you've done for Lake Kane. Thank you.
Thank you, Jay. Thank you, Jack. Thank you, Stephen.
See you soon, everyone.
Bye.
Thank you for joining us.
We have a mission at the Lake Kane Restoration Society. We want to keep it swimmable, fishable, and lovable. The lovable is part of the community.